Right. So let's get started. Today I'm gonna share some of the things I've learned from building React security AI agents, and then sort of walk over what React agents are and how they apply to cybersecurity. So we've already covered my introduction, so I'll skip that. Right. Cool. So what is a React agent? In other words, reason plus act. So you can think of it like basically three different phases. The first phase is reason, second is act, the third is observe. The, the first phase is where if you as an end user, if you ask an agentic book to or an agentic system to do something, it's the workflows or the system's responsibility to first classify the input of the user query, right? And then figure out, okay, uh, do I need to use a tool in order to accomplish this objective? Do I need to go interact with external services, APIs? So that's the first step where the system will reason through the user query and then figure out what or how they want to go about achieving that objective, right? So the second is art. Art is where, based on the reasoning that was done in the prior step, the agent decides which tools to use in order to achieve their objective. So, like I mentioned, if there are other APIs, AWS and whatnot, we've been hearing quite a bit about MCP these days, or Model Context Protocol. I think that's a great way where, if you have an agentic workflow system, you can basically integrate different MCP servers or external services. And these MCP servers will provide capabilities to your workflows to be able to bring data in from external sources and basically bring all the context that is required in order to achieve a certain objective, right? So I believe OpenAI's Agents SDK just released their MCP integration, I think, a few days ago. And MCP, if you think about it, was originally created by Anthropic. So it's good to see, two major AI labs sort of working on like similar frameworks in order to achieve objectives. Coming back to the three phases, the third phase is observe, right? At each of the steps, where the agent reasons, acts, the third phase observes, where based on the action that it took, it kind of observes the outcome and sees if it actually fits the criteria of the objective or not. If it fits, then the entire workflow is complete. If it is not, what other things will the agent want to do in order to achieve the objective? So the same cycle repeats again, right? So this is the very basic way of thinking and sort of understanding what these React agents are meant to do. All right. So you might ask, right, how does the concept of a React agents apply in cybersecurity? Well, as security engineers, we do a lot of thinking on a daily basis, right? Whether that is triaging a vulnerability, building vulnerability exploits, analyzing logs, so on and so forth. Most of this is not a rocket science, really. It is tribal knowledge or culmination of years of experience of solving similar problems, right? The a level of thinking also depends on the skills and experience of a security engineer. Uh, to give you an example, a junior engineer might not think through all the variations of a vulnerability like a senior engineer would, right? If you expect a junior engineer to go and find all the vulnerabilities in a web application, it is possible that they might only excel in a certain vulnerability class, let's say cross-section. So this is a very major important thing to keep in mind. After that, we can automate a lot of things that required thinking or some kind of human cognition, but historically have been very difficult to automate, right? In any domain within cybersecurity, we deal with a lot of data and information. A lot of it is noise, but a lot of it is also high quality data that goes largely unpacked, right? I've seen a few companies talk about building a security data lake, right, where they have all the information from their application server logs, infrastructure logs, their different like HPM vendors, like SIM vendors, whatnot. And then they analyze the data that they have gathered and they do code pulls, right? Uh, so I feel like in the cybersecurity industry, we don't make good use of the data. I mean, if a company has this kind of a system, it's good, but most of the companies I've seen and I've worked at, they don't have these kind of systems, right? So uh, the periodic history of why something was a true positive or why something was a false positive, the artifacts from security activities like threat modeling or design reviews, right? There's so much data out there which I don't think is getting used in a good way, right? So now if you combine all of these tools together, data, the reasoning, and the automation, and then you focus on your prompt or the prompt engineering, which is basically explaining the AI what you want the AI to do with all the context provided, the possibilities are endless. And so that is exactly what, the thing that I want folks to get from presenting is how can you build a system and in what format or in what workflows you build it in a way that you're able to get a reliable and like outcomes that you can trust and that is actually useful. Cool. Moving on to the next slide. So in order to understand how these React agents work and see if I can build something with them that can solve something for me that wasn't possible until now, I created this fun project called Project Cyber Safari. I've mentioned the URL here. All the code base. There's also video kind of where I wrote the entire thing. If you're interested, you can go and take a look at it. I won't have the time to walk over each of these code in this presentation, but I'm just kind of give a very high level overview of what this thing is meant to do. So you can think of it like a collection of AI agents as shown in this architecture. There's an offensive AI agent, and then there's a defensive AI agent, and there's the vulnerable application in the like center there. When you see there is serving the malicious JavaScript file. Okay, the offensive agent analyzes the file. It identifies endpoints, things like headers, cookies, anything else that is required to send successful requests to this application, right? It after that, it actually sends those requests and analyzes the response to determine if the app is vulnerable or not. So this is all done by the offensive AI agent that focuses especially on analyzing the JavaScript file. The defensive agent on the other side, it starts by reading the app server logs. As the application is getting attacked by the offensive agent, you can imagine that the a log file is getting bent. So the defensive agent starts from there. It basically looks at the log files, identifies attack patterns, and then it is connected to an internal security knowledge base. You can think of it like a security oracle, right? Where it will query that security knowledge base to gather recommended controls of how to prevent such attacks from happening that it was able to determine by analyzing the log file, right? Now, without using AI, right, it is possible to automate bits and pieces of this agentic workflow, which I'm kind of walking through. To give you an example, there are tools that can help analyze JavaScript files and identify endpoints. But generally speaking, it requires the automation to cover a bunch of variations, like different kind of headers that might be required to send successful requests. There might be some hard-coded values, right? Building any automation that covers all of these edge cases has been very difficult in my experience, right? But if you just ask the AI to do that, it has the level of intelligence that it can find some of these nuanced variation that otherwise very difficult to automate. On the flip side, if you just provide this JavaScript file to an AI, right, I can guarantee that it's going to find the same endpoints that automation will do, and maybe some other edge cases as well. So, uh, you know, and there are further capabilities where you can have your system to show its reasoning as well. So, to give an example, if you don't think the AI system is analyzing JavaScript file properly, you can have it spit its chain of thought reasoning, and then you can go each step by step and see where in this series of steps is it failing to think in the right way that you would think, right? And then you go and change the prompt or you make some changes to it. That's how I feel, we can make or we can build these systems to do things that like how human and security engineers would do, right? Next slide. So now that I've walked over what I've built and things like that, I want to cover some of the challenges, which is what the main crux of this presentation was, and the things that I learned. So there's basically five main challenges I want to highlight: tool integrations, error handling, the agency of the agents, the limitations of different frameworks, and the structured outputs. With tool integrations, I try to use different open source tools to, like to find offensive security vulnerabilities within an agentic workflow. And those integrations proved to be very difficult just because I don't think there was MCP uh, but then. So these tools and whatnot, they didn't really have good MCP servers, and dealing with input and output, and there was no standard amongst the tools, so that could be pretty challenging. Error handling, if you're building any sort of an agentic workflow system, if you don't have good observability, if you don't have good control over what kind of errors you're seeing, how do you handle them, uh, whether you're failing the system graciously or not, these are things that will really have a big impact on the outcomes of a system. So I think that's something that is worth uh, pointing out. Third is the agent's agency, right? So what I mean by that is how autonomous do you want your agents to go and do a certain job, right? In offensive security, I think it's important to give some kind of agency to agents because, you know, so let's say if we take SSRF as an attack vector, there are different kinds of exploits or different ways that you can exploit an SSRF vulnerability. It kind of depends on the environment, depends on the systems, or bunch of other factors, right? So if you are giving the agent, slightly more agency by increasing the temperature from 0 to, let's say, 0.5, 0.6, the agent will has the capability to go, totally off base and do things that they're not supposed to. But I think that is required for certain use cases where, you don't necessarily know all the possible variations, but the agentic system might be smart enough to do. So something to worth think about it, like how do you think about agency and giving agency to a system? The fourth is framework emissions. There's a handful of frameworks now, a LangGraph, CrewAI, AutoGen, and there's a and others as well. I think some frameworks like CrewAI, in my experience, they don't give you the granularity or the control over how these agents work, communicate, fail, so on and so forth. So depending upon what system you're building and how much control you want, is really important to focus on which frameworks will allow you to achieve that. Then finally, structured outputs. I think this is probably the biggest thing is, in my experimentation, what I saw was even if I gave the agentic workflow system a prescribed JSON schema that I wanted it to follow for input and output, I still saw that the React agent, it would just kind of produce JSON with some additional objects in the array. It was just very weird. So I think as some of these frontier models are becoming smarter, this problem is slightly become easy. But I think when I was experimenting like 6, 7 months ago, this was a big problem where I didn't know what to do. I had a JSON. I asked the agent to follow that JSON. It was still not following that. So that kind of broke the entire system down. Okay. Final slide. These are all the things that I've learned from my experimentation. So the first thing you've probably heard is starting small, keeping the scope extremely small, and then achieving the desired outcome, and then slowly adding more complexity. Tools, inputs, outputs, and definitions. Anytime you build an agentic system that has access to tools, it becomes very important to name these tools that kind of explains what it's supposed to do. It is important to have string like formatted description of what these tools will do, because these are the kind of things the framework will try to look at before making a decision of what tool to use, how to use, what inputs to provide, so on and so forth. Prompt engineering, I don't think I need to go into it, but one thing I'll say is, prompt engineering is also changing. Uh, uh, it kind of depends on what models you use, reasoning or non-reasoning. I'm increasingly finding out that if you're using a reasoning model, you no longer have to give end-shot examples, right? And by end-shot, I mean you give an example input and you give an example output, and you do a few instances of these to basically train the agent via a prompt that, look, this is how I expect you to behave, right? I think with reasoning models, there's no longer a need to provide these end-shot examples, because if you simply provided an objective and enough context, at least I found out that it does a reasonably good job of knowing how to proceed from step to step. Handling failures, defining maximum iterations. Again, like some of these frameworks, they give you these capabilities to switch from, let's say, how many instances you want your agentic workflow system to operate on, 5, 6. It is possible that it might hallucinate, it might go in weird directions. So you can control like all these things using some of these capabilities provided by these frameworks. Pre and post processing of data. You've probably heard about this as well. Is garbage data in, garbage data out, right? High quality data in, high quality data out. So what becomes important is before you send your prompt, your context, your inputs, everything to LLM, doing some kind of pre-processing on it in order to make sure that the data is properly structured. It is the agentic system can understand what is being asked of, and doing the same thing after the output comes out from the ML. Right? So post-processing involving any data normalization, any correction of the JSON. So like I mentioned, if the agentic system is not following the strict JSON schema, you can implement some post-processing steps where you change that yourself. Right? So that is important. Uh, with respect to model considerations, I already mentioned this now, reasoning models, non-reasoning models. There are few models that are good at coding or creating code on the fly. So thinking through your use case, what you're trying to build, it is important to remember which model will work for your use case. Thought reasoning is again, if you want to build better observability, visibility, tracing and whatnot, it's important to have the insight into how your reasoning system is thinking through and then identifying where this thought process needs to improve. And then finally, I'll just mention, uh, having a good balance of deterministic and probabilistic approaches is the best way to build any agentic system where you don't have to use LLMs in each step. If there's no need, if you can solve a problem by writing a simple like function, you should do that, right? So finding that balance where you require the intelligence and then you require simple automation is probably the way to go about it. So that's it from me. Let's see if I have any questions.
All right. All right. Thank you so much. You are still there. So I've got a couple questions here for you from the chat.
Mhm.
Um, what does your LLM workflow look like on a daily basis? What does it look like?
Yeah, so I actually use quite a few different LLMs, Claude, OpenAI's, ChatGPT, Perplexity, Grok. So, and the reason why I do that is because I don't trust any outcome from any particular LLM, right? So, if I'm asking the same question from multiple LLMs, and if the answers are reasonably similar, I can trust the outcome. So that's been my, and it also kind of helps me understand how different models work and which model would fit my use case.
And what's next?
So I think I've open sourced the project which I mentioned in this presentation. I want to continue experimenting in this space, building more agents, solving important problems that have been very difficult to solve until now, and then slowly, I want to start understanding the space of evals and consistency. Like, how do you decide whether the outcome produced by an LLM system can be trustworthy or not? I think that is probably the biggest question I get asked from from inside my company, outside is, do you build this a prototype? So what's next? I think the next stage is obviously the evolution of how can we make this thing that we build trustworthy so that the customers, anybody who can use that, can trust the outcome. So I think that's a big black box. I think there's some cool conversations happening in this space. So yeah.
Much appreciated. Thank you so much for coming on here.